Sudoku degenerates, welcome! Oh yeah, let me, it'll link to this. Hey, Q! Okay, gonna start off with the next Fortress Fillomino as sort of a warm-up. So I divide the grid into orthogonally connected regions and fill each cell with a number, not necessarily single digit, showing the number of cells in the region to which it belongs. Each region must be either strictly larger than all of its orthogonal neighbors or strictly smaller than all of its orthogonal neighbors. Modular line. Every set of 3 adjacent values on the teal line must contain one of each residue class modulo 3, i.e. one value from 1, 4, 7, 10, ... 1 from 2, 5, 8, 11, ... and 1 from 3, 6, 9, 12, ... Okay. This is going to be a tricky one to notate, but it does mean this and this have to have the same remainder, because these 3 and these 3 have to have the same remainder. Do I want to do... Oh, I have a checkerboard here as well. Oh, interesting. Because it's fortress. Let me do placeholder. So these all have the same remainder. Or wait, I don't... So these differ by 3 or 6. Now, this being surrounded makes me suspect it's low, but it could be high if it's like... Oh wait, can it be? Yeah, it could be the same as this. Okay, and these cannot... So this must be... The dual coloring scheme is just going to confuse me. But since we know... Okay, these must be different. Okay, so this is... Okay, that settles it. This is low, this is high, because this is 1. So this must in fact be the same. And this is 1, 4, 7. This is 4, 7. I'll use A for 10. realistically, it's not gonna... Oh, but this can't be 1, because it's a different remainder. So it does have to go there. Oh, this also... Okay, so this is 4. This is 2 or 3, this is 2 or 3, and these are a 2-3 pair. Because they must be different. Oh, and this is 1, 4, 7. No way is it. No way is this. Then there's no real way this can be 7, right? Oh, this also has to get out. So this is at least 4, which means it does take this. Hey, Damo. Right now I am tackling the next fortress, Fillomino. After that, oh, Andrew Sarkis, welcome. In fact, this is at least 5, because it can't be exactly 4. I think if these don't link up, then we got a problem, because max this can be is 5. That breaks this. Yeah, this is always gonna be... Or, no, it can't be 4, because it's... because of modularity. Oh, but could it go like this? Oh no, that's exactly 7. So it does have to take that. And let's see, this and this are the same remainder. Five, 6, 8, 9. A, B, 10, 11. Oh no, 10, B, C. Now, oh, it can't be the same as this, so the max it can possibly be is 10. So B and C are out. Yeah, this cannot be 7 just by... because it can't link up with this. In fact, the max this can be is 4. Which technically does work? Huh. This is 5, 6, or 8. But if it's 8, this is 2. So in fact, this is 5 or 6. Two, 5, or 3, 6. If this is 5, this is 3. Goes like that, and it takes 2. It takes that, and one more thing down here. I think this could technically be 5 if this is... Oh wait, no, these have the same mod class, so no. This is the same as this. Wait, there's no way this can be 7, right? Oh yeah, that forces this to all be blue. Yeah, that doesn't work. So this is 4. I just don't know how... whether it takes... how much of this it takes. Wait, these can't link up to each other, right? Yes, that is... should probably have, I guess this could... yeah, this... okay. This takes that. Yeah. Okay, should have got that a bit sooner. Okay, so got another 2, 3 pair here. This is the same as this. And it's the same... Is there a global mod argument? Oh, good question. I don't think so, because I could have like an extra 1 down here, or maybe these could both be 1s if this is 9. Oh, but this can't be... oh, well, I can't have one up here, but I could have an extra... in fact, I probably do need... yeah, I need an extra little mini region down here. Oh yeah, I'm really... hi, Stu! Oh yeah, I've been really liking this series. Let's see... this and this are the same. This... maybe there is a... because if there's 3... this is either 6 or 9. Oh, I don't think this can be 5 or 6, right? Yeah, this definitely can't be 5. In fact, I don't even think it can be 6. Yeah, that breaks up here. So this is 8 or 9, and I think this is always 1. And in fact, I think... doesn't this always have to be 9, regardless of... yeah, because it can't reach... the reason this can't be 4 is because one of these is a 3 and it would touch that 4. So I think, yeah, this is always 9, which means these are the 3s, these are the 2s. Ah. That makes this a 5, which makes this our last 2. Nice. Yeah, I'm definitely enjoying this this series. And that was a fun one. Thanks for the GGs. Yeah, okay. And now... Oh, no worries, Stu. Thanks for dropping by. So, last time, Elliot died in one of his very secretive experiments gone wrong. Experiment 34, Aqua. This week seems to have lasted a lifetime. The lab feels like an entirely different place now, and I'm starting to realize how little I actually knew about him. He was undoubtedly a genius, certainly not without his flaws, but beneath it all, a good man. I don't think I'll ever fully understand what happened or why he chose to keep so much from me. I expect he had his reasons. It feels instinctively wrong to continue Phase 3 without him, but if there's one thing I know for sure, it's that he would have found the alternative unthinkable. The study must be completed. Okay. So, normal Sudoku rules apply, so every row, column, and box got to put 1 to 9 once each. The aim of experiment. Finks and Finks must both reach different cupcakes by finding a path through the maze. The paths must not visit any cell more than once, cross themselves or each other, share cells, or pass through any thick maze walls. As well as moving orthogonally, they may move diagonally if there's a 2x2 space in which to do so, but may never pass diagonally through a round wall spot on the corner of a cell. Black currents. If a black current sits between 2 digits, one is double the other. That's the case here. Red currents. If a red current sits between 2 digits, one is odd and the other is even. Grapes. If a grape sits between 2 digits, they have a difference of at least 5. Video cameras. The digit on a gray camera indicates the total sum of the digits in any visited cells that the camera lens points towards before a wall is reached which blocks vision. A video camera itself cannot be entered. In this experiment, all of the low digits in the grid, 1s, 2s, and 3s, but none of the high digits, 7s, 8s, and 9s, may be visited. The two rats' paths must be perfect reflections of each other across the positive diagonal. So, like, if Finks goes here, Finks must go here, and if Finks then goes here, Finks must go here. Now, fortunately, the walls are also symmetric, or unfortunately, because it's less forcing. So, and because the paths don't cross, I know, or enter a video camera cell, I know these are not on either rat's path. Huh, okay. That does mean that Finks must go here. I don't have to worry about... I know since they have to stay on their own sides, I don't have to worry about making their paths different colors. It should be... Oh, no, the walls are not symmetric. Not... Wait, yeah, they are. Yeah, it's here. Okay, so I know these are not 7, 8, or 9. And for that matter, I know these aren't either. Must go either here or here. Now this is the only clue that breaks symmetry. Which makes me suspect it was added last. So I'm probably not supposed to use this except at the end to... I can also never put 1, 2, or 3 in any of these. Oh, and I can't put 4. Okay, so this must be 7, 8, 9, and these are from 1, 2, 3, 4. Now I can't make them both 4. So in fact, I know that these cells are visited. I'm going to use green for visited. Now, okay. And because paths can't visit the same cell, I can't take this, then go here, and then get out through here. So in fact, I know that the paths go like that. Now, I don't know if they also take this cell before touching this, but... Oh, and since all of the low digits in the grid must be visited, I do know that path visits every cell, every box. And because of this... Right. I know that this also exists. Because the path must enter this box and then get out through there. paths visit every box, so... Oh, and I also know... Oh, right, both of these are visited because this camera, I have to put a digit in this camera and it only counts visited cells up until the wall. So this must be the sum of these. Now, oddly, I don't actually know... I guess I can use uniqueness to show that this cannot be taken, to show that this cannot be on the path. But I don't want to use uniqueness unless I have to. Oh, wait, these have to both be taken and these have to both be taken for the same reason. Now, I don't know, it could go like that or like that. Because of this, it does have to, the paths do have to go like that. So, let's see, this, when you sum the dots on a black dot, you get a multiple of 3. So each of these are 6 or 9. Nice. Oh, and since these differ by at least 5, this is at least 7, 8, or 9. Oh, and I know this is odd. So it can't be 1 or 3, because then it would be visited. So this is 5, 7, or 9. Oh, but wait, if this goes up here, this sums to at least 10. So no, it does not go up here, it goes up here. Now, I know that it must take at least one more in this row and in this column, because it must take at least 3 in every row and column and box. Don't think I know... So what are the actual options for here? Can't be 4, 8. Could be 3, 6, 2, 4. Oh, those are the only options. So in fact, these are a 6, 9 pair. Nice. these are from 1, 5, 7, 8, 9. Well, these are never from 7, 8, 9. Oh, so these, oh right, these are from 7, these are 7, 8, or 9. Oh, and these are odds, so this is 8. Oh, and one of these is 9, so sees this, so that's 7, and that's 9. Oh, I've got 6 taken in here and in here. So in fact, these are, wait, what? I broke something. Can't repeat digits in this row, so this was forced. And if this takes this, then this sums to a 2-digit number. So that's all forced. Maybe it's this. Or maybe it goes like this. Yeah, okay, I was correct on this. But I was not correct on this. I know this is taken, because it has to get through here. But, right, I know it has to get up here, so it must take at least one more in here. So that is never taken, and in fact, the path goes like that. In fact, these are from 7, 9. Wait, no, these could both be the same digit. Okay, so... Alright, I can also use symmetry to prove I can't take both of these, because one of these is a 6 rather than a 9, So I will need at least one more gray in that row. Okay. Okay, so what... Oh, and nothing else. This has to be the end, otherwise this is a multi-digit number. So this goes from 6, 7, 8. Now one of these is a 5. Whichever of these is a 5 must go with 2, 1, and 8. So in fact one of these is a 1, 2. And one of these is an 8, at least one. The 5 goes with a 2 here. The 1 goes with 3 or 6 here. Now I think I could still technically put a 5 in here. Yeah, it wasn't as helpful as I'd thought. So I know at least one of these is taken. I can only have one more green in this row, or in this column, for what that's worth. What is the maximum? One, 2 with a 6, 7, or 8. No, I think I can also prove that this is gray, because, because if it's green, I can only have at most one more gray in here. And then whichever of these is 6, it's gonna break. Okay, so this is gray. I mean, I guess I could use uniqueness to show that this is also gray. Huh. No, I can't put a 5 in here because 5 in here goes with a 2, so the minimum this can be is 3. Where is 2? There is... Where can I... These can't both be 9. Could they both be 7? Leaving a 9 out out here in each of these boxes. Not seeing anything wrong with that. But, what do I do with... Should I just start using uniqueness? Because I see a couple different deductions I could make there. These being gray. I don't see any other deductions I can really make. Because these are green, because I know one of these are, and if it's here, but not here, I can't get without taking too many greens. In fact... Okay. Does that get me anything? What about... is something to do with not having enough in this column, but this and this whole area still feels very open. Okay, if this is green, then these are all from 7, 8, 9. Oh, but the 9 would cause problems here. Okay, so that's gray. So this is 9, this is 7. I guess nothing above here can be 6, or in here, for what that's worth. Because if this is a 6, obviously this can't be 6, and if this is a 9, this is 3, 6, which sees all that, and same over here. So no matter which way around I resolve these, none of these can be 6. Right, and once I've settled that none of these can be, that I can't take both of these, that does force this. What am I meant to see next? I still don't have any argument other than uniqueness for these being gray. I don't really see... If there's a 2 on here, it goes with a 7 to make 9. If there's a 1 on here, it goes with 6, 7, or 8 to make 7, 8, or 9, respectively. If this is 7, this is 1, 8, 9, this is 6. This is 4 or 5. And this is 9. And I still don't have any idea how to resolve this. It could be 1, 4, and 6, 1, 8. It could be 2 with 3, 5, or 7. Or 3 with 2, 4, 6, or 4 with, I guess, 5. Basically anything other than 9. What am I looking for? Am I meant to count? Or here. I mean, if this is 6, I know this is 8 or 9. But if this is 9, could be 8 or anything. Yeah, I feel like I'm missing something here, because I really don't see how I can possibly... I know that whichever of these is a 9, there's a... four, 5, or 6 in here, along with a high digit. So I guess this can never be 7, I think. Oh no, the high digit could be the 8. Yeah, I feel kind of stuck here. Does anyone have a nudge or... Oh, hey, Carl. What am I meant to see or do? What can I... Okay, I need to... Let me just... What is this actually? Does this force anything? It makes this 2, 4, this 3, 6. Oh, that resolves this. Okay, I guess that does... Okay, so this is a 2, 3 pair. This is a 4, 6 pair. Could have gotten that a bit sooner. Also, I don't think either of these can be 7. I think one of them is 8 and the other one is 6 or 8. So neither of these can be a 3. Whichever of these isn't a 1 is either 2 or 4. Does that... It is a rule about gray and greens. I mean, I know all the 1s, 2s, and 3s must be green, and all the 7s, 8s, and 9s must be gray, but I don't... What else does that... And there must be reflections of each other, but... Am I missing something else? Or... I do? Where? Oh, yeah. Right, yes. Oh boy. That was embarrassing. Oh, that's... I wonder how long I would have taken to spot that on my own. 3 in this box must go on here. Oh, 8. This is 6. Oh, 3 and 7. Oh, that's 3. That's 7. That's not 7. That's not 3. This is 1, 2, 4, 5. Could be 4, 5. This is 5. Can this only be 3, 4, or 5? I don't know if this is 4, this is 1. This can be 1. Alright, I guess one of these is 1. One of these is 2, for what that's worth. Oh, 7 in this box. Okay, so this is 2, 3. This is either 2, 3 to make 5, or 4, 5 to make 9. Oh, got that just as you were typing. So there's always a 5 up here, so this is 8. Oh, where does 7 go in this column? Ah, there's 9 in this box. Oh, that's 5. Oh, this is 4. Oh, and this is 3. What's left in here is 2 and 5. Do I know? I don't think I know which way around those go yet. These are from 3, 4, 6. This is 3 or 4. One, 3, 5, 8. Well, this is only 5 or 8. Oh, these are a 1, 3 pair. So this is a 5, 8 pair. Rules 8 out of there, so 8 in this column must go up here. And it's whichever of these that this does not go to. Now for this to be green, it requires these to also be green. And now I can't put 7, 8, 9. Okay, so this is gray. Oh, 7 in this box must go here, but it can't go here because then that's 8 and this is cut off, so it goes there. Can I do something similar in... Oh no, unless... 8... Oh, 9 goes up here. Oh, so 9 in this box must go here. Oh, right, this is 8. Because the 9 has to be the unvisited digit here. So 8 in this box goes here. That's 7. Oh. Well, 7 in this box goes here. Grays out these. I said grays these out. 1, 4, 6. Oh, 8 only has one spot in this box, which puts it there, which resolves this. There's a 9 in here. Oh, and 8 goes here. Oh, and that makes that a 9, which resolves the rest of the path. Oh, this is the only spot for 9 here. Is that all the 7s, all the 8s, and all the 9s? So, one goes here, which forces it up here. So 3 goes here, which places it here in this box. So this is also a 1-3 pair. Oh, this is a naked 2. But this is a 4-5 pair resolved by that. Oh, also this whole row is done. Oh, this column needs a 4. Ah, and that's going to resolve this deadly pattern. Ah, this can't be 2, so it must be 5. That's 2. These are from... Oh, that's 2. 4-6 pair here. 4-6 pair here makes that a 1. And then we have another... How do I resolve this? Oh, it must be over here. This is a 5. 1, 4, 6. That's 6. Thanks for the GGs. The rats mirrored each other's movements perfectly, continuing to perform to their usual standard as though nothing had happened. I, however, have been somewhat distracted. I keep replaying the moment in my head, the look on his face, the fall, and my futile attempts to help. Watching on from the cage, Finks had let out a long, distressed squeal. I glanced up and seen her looking down at us, scared and confused. But Finks was focused solely on her friend, staying close as though trying to comfort her. Of course, I hadn't registered it consciously at the time, but that image has stayed with me all week. Okay. Ah, thanks for the applause. I wonder how long it would have taken me to get this if someone hadn't if Carl hadn't drawn my attention to it in chat. Oh boy. And but yeah, that was Really neat. Love the aesthetics of this. The increased cameras and such. Yeah, very curious to see where this is going as well. And on the note of oh boy, think I'm ready to tackle this. I need to refill my water, but I guess after that we'll find out. And yeah, let me pin the link. I guess we'll find out in a few minutes. Alright, be right back. Hello. Oh, hey, Senny. Sorry, that delay lasted a bit longer than I had intended. I had to help Mom with a storm window. Actually, wait. Where's full screen? There. Get a little extra screen space, because that's going to be at something of a premium for this puzzle. I mean, I'm never going to fit all the rules on one, especially not if I increase them to a readable size, but abnormal Sudoku rules apply. We're off to a start. Fill the grid with the digits 0 to 9 and the letters MDPRBC. I do think hexadecimal Sudoku is also underexplored now that the letter tool is standard practice. Okay, fill the grid with the digits 0 to 9 and the letters MDPRBC so that digits and letters do not repeat in any row, column, or 4x4 box. A value of a letter equals M mimicry. A value in the cell rotationally opposite itself in the grid. So, like, this would copy this, and M cannot be mimicked by another M. Position. A position within a box number. Positions within a box are numbered 1 to 16. Oh, not 0 to 15? I would have gone 0 to 15, but okay, I will accept 1 to 16. Row number from 1 to 16. Column number from 1 to 16. And box number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All constraints are standard, like in 9x9, except of the modular line. This is a 6 modular line. Okay. So Kropke dots join values in a 1 to 2 ratio. And the white dots join consecutive values. Values along an arrow sum to the value in the circle. I mean, this must be 15 or 16. Oh no, but I have a 0 now. So it must be at least 10. Or... yeah, even with position, this is at least... well, anyway. Okay, palindrome. Values along a gray palindrome read the same. Okay, that is interesting. Lockout lines. Values on an ice blue line cannot be between or equal to the values on the diamond endpoints, which must differ by at least 4. Zipper line. These sum to this, these sum to this, these sum to this, and these sum to this. And any 6 values on here must have different remainders when divided by 6. Seven, 8, 9, 10. Okay, so there's 10 values on here. Adjacent values on a German Whisper line differ by at least 5. Values on a yellow line form a set of non-repeating, non-consecutive values in any order. Okay, I should probably start there because... yeah, that must go from... well, let me finish reading. Okay, and these form a set of non-repeating consecutive values in any order. Okay, that is all the rules. Okay, this Nabner, there's 8 values on there. Doesn't that mean it has to go from 0 to 16? 0, 2, 4, 6, 8, 10, 12, 14. Oh no, that's only 14. Huh. Alright, oh, did I read out... oh. This is the sum of all these. Okay, maybe that's where I start. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what is the maximum I can actually make this? If it's diagonal, it's 9. Same with column. Oh, but mimicry, it could be 16. Okay, so... how many... okay, say I put P here, and R in here, a 0 in here. Well, RB and 0... and another mimicry to take another 0. So we're here 3, okay. 0, M, that's 0. One, 2, 3, 4, 5. Oh, diagonal here could make an extra 2. So this, on its own, is already 7. But that's... I can't make 17, so how do I lower this even more? Obviously, R goes up here. Obviously the M would not go here. I'm just using this to take notes. I'm not worried about other clues. Oh, but the box is 2, so that's 8. Because column, that's already 5. And And that's all the modifiers available. But I've still got... I mean, I could fill this with C, but there's no reason to, because C is already going to be higher than 1, 2, 3, 4. So I have to swap one of these with something lower to get it down to the point where this can be an M. Seeing a 16, seeing something with a value of 16 here. But how do I... Oh, no worries. I just got started a couple minutes ago. I was on my break and I haven't had any... Yes, yeah, this I'm just trying to, like, min-max. I do not think... Well, I'm reasonably... I'm guessing this P is correct, but everything else... And I'm guessing one of these is an R, but, that's about all the rest of these could go... I'm just taking notes for a min-max attempt. Oh, and this D might be required. And I'm pretty sure this is an M. Copying something with a value of 16 there. This is 4, 5, 6. Oh no, that's only 6. Oh, okay. So that is actually... Okay. So, okay, so that does get me this. Boom. And I know that there is an R in here. And the others on here are from 0, 1, 2, 3, 4, B, and M taking a 0, taking the 0 in this box. Or something with a value of 0. Yeah, 0 is the only thing that can have a value of 0. Now, okay. I know that this is 1. So, it's possible one of these is a 0. Oh, this can't be R. This is R. So this is not 1. Or 3 or 4. So this is also from 0 to BM. Oh, can't be M. So I know each of these has a value of 0 or 2. Now, if they both have values of 0, this is 1. And if they have different values, this also has a value of 1. But if this... I guess I could also note that these are the only positions for 0 in this box. Oh, and I also know that this has a value of 16. So it could be... Oh, is that only row? Is row the only thing that works? Yeah. Yeah, this is row. This is an R. Wait, no, that doesn't work either. What? How is this? Oh, position. Right, position also works. Box does not work, column does not work. Diagonal would only be 8, and an M can't take an M. So this is position. Now, if this is 0, these both have values of 1. Oh, this can't have a value of 0 in that case, because I can only have one more value of 1, and it's the actual 1. Because box has a value of 2. So this must have a value of 2, which removes the 0 and the M, leaving 2B, or not 2B. Now that doesn't tell me this. Okay. So this has a value of 2. So this has a value of 1 or 3. So it is not... Oh, and it can only actually be 1 or 3. That also removes these from being 0. Now this RSL is also... But, I mean... The fact that it has another cell here means it's not quite as restrictive. Okay, so this also... Oh, so this is the other of 1, 3. So this is also not 0. Now... Oh, I think 2 and B are the only two ways of making 2 here, right? Oh, and this diagonal being... Oh, this diagonal being 2 also made that... well, made it 1 or 3. Okay, I don't think that... Okay. Yeah, there's no other way of making 2 in box 2, because column... I've already used the row and the column. So I think this being 1 breaks. This is 3, this is 1, which annoyingly does not actually resolve... whether this... Oh. Okay, so this is either a C or an actual 6, right? Because I've used the M. Oh yeah, I should also clear out the... So this has a value of 2 or 4. Now if this is a diagonal, it's 2. Oops. Row is 3, so that won't work. Box is 1. Column is 4, that will work. Or, of course, the actual 2, 4. Oh, and mimicry, right. Okay, I probably shouldn't... I'm not sure I even want to bother pencil marking these before at least I... Yeah, because even with that, even now that I know it's... Oh, well, maybe this is a little more restricted, because this cannot... Diagonal doesn't work here. This is 1, so this has to have a value of 2. So row, column, box, diagonal. It could be mimicry. Oh, it can't be because of that. Because it sees 1. Box. Box is 1, doesn't work. Column is 4, doesn't work. Okay, so this is only an actual 0 or 2. And 1 or 3 here. It can't be an actual 1. Oh, it could be a box or diagonal, though. Oh, and this could also be mimic. Okay, so we're getting... Okay, I don't think I can make that much more progress here before I... Or maybe, wait. This being 1 or 3... Oh, this could be diagonal. Or box. Or mimicry. 1, 3, BD. Yeah, we keep... Yeah, I think I need to know more about... Well, this can't be M. I think this is 1, 3, B, or D. And this is 2, 4... D. Oh, or C. Yeah, there's still... Oh, but wait, this... Oh, the palindrome. I hadn't thought about this and... Okay, so this is also... How can this be 16? Oh, this is position. So basically, the other modifier, the other variables all appear on here to get... Okay, if R goes here, goes with a 2. If it goes here, goes with a 2 there. 3 there. 3 there. Oh no, 4 there, 4 there, 4 there. Alright, what about... Hey, Jojo! So, okay, the box goes with a... oh, wait, the B goes with a 3 always. So, since those can't be 3, those cannot be B. Which means the R can't go here. Or here, so one of these is the R. Goes with a 2 or a 4. There's a few too many B pencil marks here. It's getting a little cluttered. Okay, so B goes with 3, R goes with 2 or 4. Diagonal. That goes with... if it's here, it goes with 8. 7, 8, 9. Oh, it can't go here because there's no 10. What about column? Oh. Oh, this is C. So this is 9. So I know the diagonal does not... oh. Oh, 10 or 11. So the diagonal goes down here. Oh. Thanks, Abyss. So this is now an 8, an actual 8. So the row goes with a 4 up here. Yeah, this is a really pretty puzzle, isn't it? Oh, and... Aw. Oh, glad I... Oh. Okay, this no longer being a D. And the box either goes here with a 1. I guess the only actual options here are... Oh, wait. The row goes with a 4. Oh. Okay, these are from 3, 4B. And these are 3BR. So this is either a 3 or a 4. Now, have I... What does a person, a crate, a fork, and a mood have in common? They all need a lift. Oh. Ain't that the truth? Oh. Oh, not quite. Nah. Oh, that's a cute emote. Ah, that's sweet. Sometimes my, yeah, when I get hyper-focused, and it kind of helps, it doesn't help that I kind of have resting bitch face, as it were, so sometimes it looks like I'm scowling when I'm actually just neutral-faced. And sometimes my... brain doesn't update my face with my expressions proper. What does a labyrinth become when it feels pain? Let's see. Brain not bad. A mosaic. Oh, I'm not quite sure I get the... I know mosaic. A mosaic of pain. Oh, a window? Is it a... Brain not passing the emotions to your face is a mood, yes. Yeah, that's... Maze ache. Oh, okay. Let's see. Maybe I can do more in here than I assumed, because... Or maybe it's... Oh, which mysterious song on the internet? Oh, maybe I can do more in here, because the modifiers... Subway of Your Mind by Fex. Oh, I don't know if I've heard that one, or maybe I have heard and just... Since it was a mystery song. Or wait, is that one... I saw an article about some mystery song finally getting solved. I can't remember the title offhand. Okay, like, what is the minimum? I guess the diagonal can get this as low as 2. Oh, and position could be 1. I could repeat a 1. But row, column is going to be at least 9. Oh, it's going to be more than 9. Box is 15. Row is 13 through 16. Oh, and I could use mimicry to copy a smaller number. So, okay, assume that I have an M take a 0. Oh, neat. Cool, I'll check it out after my stream. Thanks. There's, ooh. M. Okay, let me just take some notes here. If I assume that it's M with a 0, position here, diagonal here. This M could go anywhere. Oh, finish one of childhood games. Which one? The Incredibles? I've seen the movie. I haven't played the game. What else? Okay. 0, 1, 2. Oh yeah, they did a lot of tie-in games. Most movie tie-in games were shovelware, but there were a few that were actually good. Was oh, good. That's okay. If I assume that that's all I can do with values smaller than... Oh, and another 0 here or here. 1, 2, 3, 4, 5, 6, 7. That's 28, 29, 31. Oh, and this has to be... Okay. So... This has to be... Oh, wait, this copies this. Oh, but there's no way this can be 15 or higher. If this is M. This would have to be... probably R? Because, yeah, diagonal doesn't get it high enough. Column, yeah, there's no way, because I've used all the variables on here. So this would have to be... So this would have to be the R. And now I have to... Okay, this cannot be 0. So this cannot be the mimic. But similarly, the mimic has to copy a 0. Where are the... This reflects here, this reflects here. Okay, so these are 0Ms, and these are 0M pairs. Oh, that is cool. Should have looked at that sooner. Okay, so no 0... Oh, that's also 2B now, or not 2B. So this is 4. Oh, and this is 0. This is M. So this is 0, and this is M. Oh. Alert? Oh, right. So any of these could be M. Okay, that is less... Oh, but one of these, it has to be one of these. So 0 has to go here, 0 can't go here. Okay. Still, that's some progress. So this is 0, 1, 2, 5, 6, 7. That's an awful lot of... Okay, what else can I... I guess B in this box has to go on a... Oh, and this is 0, 1, 2, 3, 4, 5, 6, 7, M, right? Because there's no way to get any of the other modifiers besides P and D. Yeah, row is too high. Column is always too high. Box is definitely too high. So this is 8, 9, No 8s here. R, B, and C, right? No R's here. Okay, that'll be presumably useful for... And R in this box cannot go on... cannot go down here, because it would need to be on an arrow circle. So R must go somewhere in here. Probably in another circle, because... Okay, B always goes on an arrow circle in this box. Oh wait, this... This is 2. This has a value of 1 or 3. Let me just fill that in just so I remember this has a value of 1 or 3, because this being B is impossible, right? There's no way to get that many, even if, like... Even if this is 3, I can't... Oh, 0, 1, 2, D. That does technically work. Maybe I should think about this arrow. Just without... Oh, and I should also... In the interest, this could also be B. Can't be D because of that. R, well, that's too high. Column also too high. Oh, it could also be M. Mimicking... Oh wait, it can't be M because these have to differ by 4. At least 4. So I think this can only be a regular 1 and 3 or a B, right? Because this... Now, it would be very inconvenient to have to do... to have to make all of these not in between 3 and 16, but, or the same as those. But it's not obviously impossible. But what about this? I mean... Oh, I could have a 0 and an M taking another 0. So that's... Oh, that's actually not... Maybe I'm not supposed to look at this yet, because it's still, like, super... Because, like, even this arrow is, like, really open-ended. Alright, where else can I actually look? So this has 8 values. That could go from 0 to 14, or from 2 to... I guess if I know there's a 2 on here, then I know there's a 16. What is the max this can be? I guess if it's a B, it could be 10. If it's an M... Oh, this can't be a P, so... Oh, it could still be a C to be as high as 12. Is that... Oh, that is nice. Well, no. Oh, no, I spot something. Oh. So I know this is either 3 or 4. This is a length 10 line. So the max I can put on this is 13. But none of these are necessarily inclined to be higher than that anyway, unless it's M shenanigans, but that's... I guess the fact that they can't repeat might be... The fact that I've rolled... Okay, and maybe I should... Maybe I should think about this. Oh wait, no, that's... It's this. So, there is one modulo group that only has 2 options. How would any of these... Oh, I guess one of this is on the diagonal, it could be an 11, or here, a P here being an 11. Oh, this... Yeah, D is pretty restricted, so it would be... Huh. A column here or here could get me 16 if need be. Diagonal here. I guess I could repeat values. I'm not sure where else I can actually look. Could I do more with the... I know this is at most... What did I say? At most 12, right? This is 0, 2, or 4. What modifiers work there? Well, it can't be diagonal or row. Could be mimic, annoyingly. Ooh, this being... That would be tricky, but not undoable. Oh, maybe that's more restricted up here. Oh, no. It's less restricted because R and D are available up here. As well as mimicry. Yeah, that's too many. So close to a quad. These are from 5, 6, 7, 8, 9C. I guess 9 can't go here, so it only goes here. Can I do something with this? Column will be from 13 to 16, row will be from 5 to 9. Box will always be 8. But it's just so... Where would I even start to look for... would I even start to narrow down the possibilities here? Because, like... there have to be a bunch of copycat, a bunch of repeated values in here, but I don't see... I mean, there's at most 2 distinct values in here. And in here. And in here. But there's so much to... so much to choose from. I guess I can't put a 0 on any of these, because I can never get a modifier to equal 0. Oh, unless it's a mimic with another 0, but no, then that only gets me so far, because if I put a 0 here, then literally all of these need to equal 0. So I guess there's a 0 up here. I guess the longest unbroken chain I can have with no repeats is 1, 2, 4, 8, 16. I guess the R in these two, but I have a bent X-wing on R's. Rules R out of all these, for what that's worth. Can I have, like, 3 of the same value if that value is 4? I can't, I have no idea how, this looks like it should be so forcing, but I just don't know how to even approach, where to begin. Huh, what about over here? This is 1 or 3, so this is 0, 2, or 4. Now diagonal gets that. Position does, but it can't be position. Oh, and column does that. Does as well. Box doesn't, though. What about... If this is 0, this could be 1B, making it 2, 4M. Does 0B pair here? Oh, but if this is 0, that's B. So that's 0, so that's M. And that would be 0. Okay, does that cause issues? Yeah, I think I am about due for one, because at least a hint on where to look next. Oh, this cannot be M. This could if I had, like, a bunch of very low... Actually, I'm not even sure this can't be M, because if I had a D in here, along with a 0 and an M taking a 0, yeah, this could technically be a 4. I think I might need that nudge. Where? Oh, it is. Okay. Okay, how do I begin? I know there's at least two repeats in here. At least one in here and at least one in here. But if these are the same, it still only needs 3. I guess, okay, if I assume it's something like 3, 6, 12. I don't think I can possibly get enough. So do the values all have to be from 1, 2, 4, 8? And is there like an elegant way of proving that? And also, does that mean that the actual 1, 2, 4, 8 have to go on here? Because with 6 variables in each box, it's just, I don't see how. Okay, if I assume, oh, 4. Oh yeah. Okay, so it's 1, 2, 4, 8 and all the modifiers. Okay, so how do I arrange them? Okay, column can only be 13 through 16. The only one of those that works is if it's 16. So that's the column. The row has to be 6, 7, or 8. Only one of those that's a power of 2 is here. Box can go anywhere and it's equal to 8. The position, 8 or 16. The diagonal, 6, 7, 8. Okay, must go here. Mimicry can do anything. That's C, D, P, and R. Although I guess it being on here, wait, this, I do have to be careful with the M if it takes something here. Okay, but I know that the column 16 and position 16, position 8 or 16, well, this has a value of 8 or 16. Oh no, the mimicry takes from here, not here. Okay. Okay, that is... less helpful. Okay, so I don't have to be careful with mimicry at all. So I know there's an 8 in here. And I guess the even powers of 2 or no wait. Yeah, 4 and 16 have to be an even number of steps apart. Same with 16 and another 16 if this is... The diagonal is always 8. So there's an 8 in one of these. So these have a value of either 4 or 16. Oh, this is not R. Now, if this is a mimicry copying from that, I don't think there's any way to make this 16, right? Yeah, it has to be... Yeah, okay. So these have values of 2 or 8. Because I do get sort of a checkerboard, like these have to be the even, the odd powers of 2. So this cannot be 16. Oh, and this cannot be position. So these are 16, so these all have values of 8. These 8 box or mimicry. 2, okay, this is not 0. And this is DR 8, B, or M. Now I'm out of 16s, right? So this has to be 4, right? Oh, and I think the only way... Oh, this could be an M. But I think the only options are 4 and M. Right, but since this is an 8, this is also... Okay, 4M pair, right? Those reflect over here, so this becomes 4. So, there's no more M's. So this is 8B. And this is D or R. Now, this can't be R because this can't be 4 or 16. So this is R. This is D. Okay, and since this is D equals 8, this is the 7 or the 9. Now this... Okay, I've used up all the... Yeah, so this just has to be 2. And I think it has to be an actual 2. And now this can't be 4, so it's got to be 1. Oh, this is... Oh, this could be a D. Or an 8. There's no B on here. Oh, and this is... Oh, this could be a P. Alright, or a 4, or an M copying another 4 here. Oh, having a 4 in one of these. Oh, I guess 4, I mean, yeah, like any of row or box, or even diagonal on... Okay, diagonal here or here. Yeah, this being a 4 is not an issue. This is 8. So this is diagonal 7. It is... I don't think this can be 16. Is this also 4 or M? Are those the only options? Row combo. Okay, so one of these is a 4. Oh wait, does that also get me the same thing down here? Column is used up. Diagonal still doesn't work. Oh, wait. This could be an M taking... Or wait, could this be a 16? No, it can't. Certainly not if this is an M. Yeah, so I think I get another 4M pair, which makes that position. And these have to be 2 or 8. In fact, I think they have to be actual 2 or actual 8. Because those are the only... Okay. So, in fact... Right, and there's no way for this to be a 16 either. So... I note that these are the same symbol, and these are the same symbol. So either these are both 4s or these are both 4s. And either way, this is next to a 4. So it must be 9 or higher. Can't be position. Box doesn't go high enough. Diagonal doesn't go high enough. Even row does not go high enough. Column can't be position. Diagonal O. Mimic. Oh wait, no, this has a value of 8. I think this just has to be a 9. Oh, this could be position. Oh, wait, what about this? If this is 4, this also has to be 9 or higher. Without being position, and without being... It'd be row, column, box, position, diagonal... Can't be mimic because this is only 8. I think that forces this. Now, okay, down here it is pretty easy to get the variables higher than... to get the variables 9 or higher, but up here it is trickier. Row, column, box don't work. Position would work here. Diagonal does not work. Mimicry... This is 8. This is a max of 8. So I think this is only position. Oops. And this... Does that mean this has to be mimicry, taking a 9 here? Or a modifier that's higher than 9? In fact, how many modifiers are even left in here? Can't be M, P... Diagonal does not get high enough. But it could be row, or box, or column. Well, it can't be column, but it is row or box. Are those the only options? Oh, or it could just be a regular 9. This is a 9, a B, or an R. So this is a 10. So each of these... Oh, well, I could theoretically get another 16 in here somehow. It'd be very tricky, though. Somehow, maybe. Alright, but... these either have values of 16 or 5 or below. If it's box, this is 12. If it's row, this is 11. This could be 9. Okay, let me look at this. Let me clear that color. It's no longer any use. It's not... 9. This is not 9. Now, R is still... R is viable. Box is viable, because this is box 9. Diagonal is viable here. Column does not work in any of these. Position does not work here or here, and these both see... Oh, well, this one also sees that. So it can't be position. And... I guess... Wait, what are these? Oh. These can't be mimicry. Okay, so this is a 9 BDR quad. And interestingly, I always know this is exactly 9. Oh, this can't be 4. Position in here. If it's here, it's 2. If it's here, it's 6. Alright,
What did you say again? I meant, forget that. I got too, close to sin and my head's all foggy like. So, I don't know where this place is. Or even where
this is 1379. And it's only those, because none of the variables work.
Sin's toxin got to you, but you're still alive. Praise be to Yevon. Praise be to Yevon.
So, this could theoretically be 14, 15, or 16. That would be... Wait, there's no way for this to be as high as 14. Can't be an M. These are the only options for M. Let's see. I guess 4 in this box can only go here. Where's... Or goes with 4 up here. 3B, 3B. Mimic doesn't work here. Annoyingly, it still works in any of these. So what can I... I guess this is only 1, 3, 5. Wait, if this is 5... still put an R here. Can't put a D. Can't put a B or a C. If this is 5, this is 10. But I think the only way to do that is with the position, and that doesn't work, right? Oh no, I could use a mimicry. What does that take? It takes this one, right? And if this is 1, then this is 4. These both have values of 2. Oh, if this is 1, then all of these have values of 2. Is that... We could put a diagonal up here, column here, an actual 2 here, or just, you know, another... Well, this definitely can't be 2, but... Is it... Can I do more with this now? Oh, this can't be a mimic. So... I think max this can be is 10. That's if it's row or box. Column would make it 5. Position would make it 5. Diagonal is 5. It can't be a mimic. Right, yeah. The max this can be is 10. So I have to be... Where is this? Can I do more with this? Huh. I think I might need another nudge, because I feel like I've hit another dead end. I need at least 3 modifiers on this. Where do I... What can I... D only has 2 spots left where it's not on this diagonal. This is 5, these are both 4. I think the only way to do that is with a 4 and a mimic. I guess position only has 2 spots in this box. If this goes here, it is... Oh, thanks for the raid, Flinty! How was your stream? Hey, thanks! Drunked Flinty raid, oh boy! Well, welcome in, everyone. And Damo, hey. Ah. Most men can. So that's the 1-star puzzle I've heard about. Yes, yeah, yes, that is. I've been at this for 100 minutes and I've made some progress. Yeah, warm-up puzzle. I might have to... Oh, wait. Oh. This can't be 5, because I'd have to have a 4M pair here and an M here. So this is not 5. So this is only 1 or 3. Now, that means this is 2 or 6. Now, as for modifiers, it can't be diagonal, or variables, I mean. It could be column. Ah, welcome back, Senny. Is that the only... Oh, it could be... Could be, mimicry. I feel like there's some kind of sextuple or octuple in here, but I have no idea how to find it. Box 5. Oh yeah, box 5 has box 1 above and box 9 below. So yeah, it's sort of flatmates. Let's see, what am I... Do I see anything in... This being 1, 3, or 5. I guess if this is 0... This has to be a B. 2, 4, M. B, 0. Honestly, at the rate I'm going, I may have to make this a multi-stream puzzle as well. What's... Okay, so... I guess the position here would... Here, if it goes here, it's 7. Nine, 5, 3, 1 below, and 4 above. So I guess if this is position, there must be a 1 and 3 and 5 on here. Or 0. Good night, Flinty. Let's see, where? Yeah, no hurry. Take your time. Take plenty of time. Is it diagonal? It's 12, 15, 14, 16. Yes, please. I could use another. Where is... I mean, this being a mimic is difficult, but not impossible. Same with this. And this, I eliminated 5 from here. But like... anything else I could possibly eliminate would require so much look ahead. I guess this is 0, 2, or 4. It can't be... Oh, good point. Wait, let me... before I... MDPRBC... Okay. Alright, I can't put 9. I can't put anything higher than... I can't put anything higher than 3 here. Can't put, or here. Or can't put anything higher than 4 on any of these. So this is 5, 6, 7, 8, 9, and... Okay, so that's 6 and 9? Okay. Oh, so this is 3. So, it's not 1 or B. So this is column or row. Okay, so this is 3. Oh, this is C. So this is R. So I guess there's no actual 9 on here, for what that's worth. I guess there's only 2 spots for the actual 1.
I wanted someone, anyone beside me. So
If this is 1, this has to be 4. These both have values of 2. Or 0. Oh, this could be 0, this could be 2. I don't think either of these can be an M if they're 2. Well, maybe this one. Oh, no 9 here. Makes it slightly less likely that this is 8, but only slightly. Or maybe more likely that this is 8, since that will resolve this if it is.
A little better, maybe.
Oh wait, this is a 2-8 pair, duh. Okay. Am I missing anything else obvious? Don't seem to be.
I remember that night we talked for the first time. I didn't know it then.
024 RM.
Changed for everyone.
Oh, I've used the R. Oh no, this could also be a D. Oh wait, no, this can't be 0. So I guess the only things left here is either a 3, a D. Is this a sextuple? 2, 3, 4, B, D, M. Yeah. Okay. So what's left in this is 0, 5, 6, 7, 9. P and R. Oh? Oh dear. Oh dear. Oh no. It does? How? Oh, it could be an M. Let me go. I guess there's only 2 spots for the R in this box. Three BDM. 2 for RBDM. And that does not make a sextuple, so it doesn't even get me anything. One of these is 1, one of these is 0. What am I supposed to? Where is it? If either of these are 3, this is a quintuple, making that an R. Okay, do I get, what is this? I mean, this all looking down. I guess it's kind of forcing on here, but I don't see. What do I? Yeah, I think I need. this isn't B. At least one, and I mean, this could be, oh, at least two, the one and the B. And possibly the D as well, and maybe the M. So, what does that tell me? I know one of these is a 1, one of these is a B. And there's a 0 somewhere in here. If this is 4, these are 3, so this is 1, this is B. So this would be the 0. If this is 4, oh, this can't be 4. Does that rule anything out of here other than 4? No. Alright, this has to be 2. So this is a 4, so this is 3. If these are... that's not 0. So there's a 0 here, so this is not diagonal. So... oh. No 3 here, so no B up here. So no B here. there's a 0 up here. Well, these can't both be 0. But, of course, even if these were both 2, that wouldn't actually change. Oh, if this is D, that would affect something. Oh, 2, 4, B, D, M, right. Two, 4 pair here, so that's 0. Oh, that's... This can't be D. Okay, that's B, that's D. Let's see. And now I know that this has a value of 3. Oh, this is 2, this is 4. Yeah, quindeciples are not the easiest thing to spot in this. These are just 5, 6, 7, 8, 9, right? Oh, this is 9. Okay, this is still 3 or 4. Oh, what's that a reference to? So one of these is 4. Oh, I keep wanting to watch more of Ollie's streams, but I'm usually asleep due to time zones. Two, 5, 7, 8. 2, 5, 6, 7, 8, D. Yeah, these are not gonna... Oh, and this... Oh yeah, that makes this a 0. Sorry, and this... makes this an M. Oh. Okay. So I have X, B, R, and 8. Roll out of there. Alright, There's a 6. Oh yeah, this has been... Yeah, I rewound too far when I... Eight here, 8 here. Not really... Oh, this isn't D. Oh, so this is D. Okay. So that's exactly 9. And this is exactly 9. Okay. These are from 1 to 7. This is always 9. This is either 9 or 11. ASD in this box only goes in those. I guess it could go here, theoretically. Honestly, I should probably leave it off there and just see if I can finish it on Monday. There's a C here. Okay. Alright. Meantime, let me see how much progress I can make on, how much more progress I can make on Rorschach's River. Yeah, I got that impression from the from the LMD comments. Alright, I do need to refill my water. I'll be right back. Okay. Okay, I know that this... I know that this does not go here. How am I supposed to even begin to... And in part 2, it gives some stuff I don't have just from this, right? So I am supposed to do some stuff here before I... Okay, if this goes... must go there. Okay, if this goes here... Oh, this would have to go down, this breaks. Okay, so this does not go here. So this turns down here. This can't link up, so that does that. Another way, the hint said, another way to think about this constraint is each symbol must be adjacent to different symbols on the path. To two different symbols. So each letter must go next to a different letter on the path. Oh, this has to take that. Is probably... Oh, this... Yeah, that forces this. Okay, this could go straight down or do any number of things. Oh, but wait. This is the first time... This can't be the first time this encounters a letter. So it must, in fact, do that. Oh, and if this... Oh. Huh? I thought I was proving this couldn't work. Huh, that's weird. Why does this break? I mean, it forces this. Well, let me work over here. What? This... Oh, this can't go straight across, so this must go down. Oh, and now if this goes down... Oh no, that still works. What am I... Why would this... Should I assume this does do this? If it doesn't do this, what does it do? it doesn't do that. Oh, well, this can't do that. So I know that takes that. Oh, and if it goes here now, that breaks. So in fact, this does have to do that. Okay. There is... how do I prove this goes down? Where does this exit? I guess I could just start by... Why does this break? Well, it forces this. Oh, and then... Okay, if this goes like this... Well, it can't take this or this, so it has to do that. And now this can only go like that. So this has to go... Right, and now it can't exit here. Oh no, wait, this works. How... Okay, this... Oh. This is forced to do that. Okay. How does this take... Oh. Wait. Oh, wait. Okay, so I know how this exits. Okay, so it doesn't care about the lines down here. I think this is forced because the path visits every cell. Or well, this has to go there. Oh, this... Exactly how much... Why does this break? Oh, well... Oh, then this cell isn't visited. Right, okay, so that... Okay, so let me just... Okay. Oh, but here... Okay, now we're... Yeah, this is for... Wait. No, it's not. Wait, I think... I don't quite get... Does it have to... I'm gonna check the solution just to see if it... Oh, okay, so it doesn't... Well, this is forced, right? Yeah, okay. But these don't link up to each other. What did I say? Oh, right. This goes down. So this becomes a... Yeah! Bug in here. Not a harmful one though, I don't think. So, where do I... How does this get, okay, and... Oh, this has to go... Right, and it can't go up. Okay. So let's, oh. Well, this does not link up, so that goes down. Oh. I don't think this can go down. It's a little tricky to say. And I might be overlooking some way it can. This goes down. Oh, that breaks this. Yeah, so this... That's correct. Yeah, okay. Just making sure. Okay, so that becomes... Oh, these cannot link up now. Still can't link up. Oh, these can't link up. This has to... Oh, this does not go there. This has to take another O. Oh, this has to take that, because it can't take another of the same symbol. Okay, that makes this a corner. And this can't take an O. Right. So that forces that. Alright, what can I do about what's that done there? Oh. Can I small or nothing? So at least 2 of these are visited. Oh, this can't link up with that, or it doesn't take enough O's. Okay. Oh, that can't link up there. Therefore, that. This can't link up to an O yet. Oh, these can't link up. This goes oh fuck, I broke something. Oh god. Where's that? Okay, correct up here. Looks like. Okay. Oh. Where's the... oh. This can't link up. That's forced, because this can't go straight across or it breaks. Oh, wait. Right, if this goes down, break, that has to do that. Okay, and that forces this. I'm guessing that's the last one. Not necessarily the only time it exits and re-enters this. Okay, this is a bold outlined region, so it has to go there. This... well, I know this is visited, because it has a letter in it. And it can't leave... there's no bold outline. There's a thin outline here, but not a bold one, so... this, I think this is all forced just by that. And similarly, I think this All for, oh, but that can't. Wait. I think I broke something down here. Oh, wait. No, this could link here. In fact, it has to, because this only links to an O. So that's forced. This cannot link. Okay, so that's forced. Oh. I think that's going to be forced at some point, but let me see if I can. This has to go up. Oh, and this can't. Oh, it could go there. Wait, no. Oh, there's a parity problem if it goes here. Because now it can't take all of these without leaving, before leaving. So it does not go there, it goes up here. Oh. Forced corner. These can't connect because wrong number of O's. These probably connect. Oh, this has to connect to that because of that. Okay. But this does not connect to that, so it does do that. Forces a corner there. Oh, and this is also... Okay, so that's forced. Basically, the shape of this region forces this, and the fact that I know it's entered. Now, the thing is... Oh, I know this does not go down, because now we have... It's a little... I don't know of a rigorous proof, but it shouldn't be too hard to see just from looking at this shape that if it enters here, it can't visit every cell before leaving. So that is not an option for an exit. Neither is that. Oh, and if this takes the... Okay, so this goes in here. Alright, oh, this cannot... Okay, that's forced. Oh, if this goes down, we have a P next to two O's, so that does not go down. Oh, and if this goes this way, then that goes that way, and we run into the same problem. So this does go here. This can't go there. So this does have to go here. Okay, so this part is done. Now I just... Okay, so this... is never entered. I'll use light gray. Or maybe just green. So, well, I know if this enters this, if this goes this way, it goes here, and now I have to enter here. But if this goes here, it enters here. Either way, I know... And I know it goes here. Now... Oh, here we have a problem if it goes here. So it goes down here. And now if it enters here, it can't. Right, so I know that this is entered. It's all or nothing is interesting. Is this an established puzzle type, or did they make it up just for this? Oh, and since I know this is never visited, I know this is visited. And this is also visited. Oh, cool. Okay. Might check out some of these. Okay, and because this is unvisited, this has to be visited. Now... Okay, if this is visited, it enters here and it enters it from here. But if this is unvisited, this has to be visited. So... I know this does this. Oh, interestingly, these can't both be visited. Because if this is visited, that cuts off this. Oh no, this could be visited if that does that. Oh, that might cause some problems. Not necessarily. Oh, if this goes down, it creates a dead end here, or a mini loop. So instead, this does have to go there. Oh, and now if this goes this way, that creates a mini loop. So this does not go that way, it goes this way. Now, oh, this can't go that way. So it must go this way. And it doesn't mean this isn't visited. Oh, if this goes this way, creates a dead end up here. So this does enter this, and I know that... Okay, so now... So this... Oh, I think if this goes this way... Oh, this could be the last one visited. Oh, this is forced to go here. Oh, hey, Michigan Josh. Welcome. Oh, now this is... Oh, myopia. Okay, because I couldn't... Oh, right. Good point. I could loop back around this way. But this is forced. Okay. Okay, so I could have this, or... Oh, wait. This does not work. Because if this is visited at all, it must enter and exit through these two cells. This works. Oh, wait, no, it doesn't. Because to avoid, like if this takes here, this has to loop around this closer. So in fact, this is the only thing that works. I can also X out anything that an arrow does not point to. Now, if this is a distance of 2, oh, that does work. This might be a little too cluttered to risk. But, this really, like, I mean, nothing approaches. Oh, well, this is forced, which means this cannot be x'd, or this breaks this. Because this would see this before this. Oh, yeah, Jalen. Cool. Can't X out all of these. Oh, I think if this goes down, it breaks this, because this is going to be uneven. Oh, unless it goes like that? Oh, but then I'd still need... Yeah. This cannot go down. So this has to go here. Now I could still go down like that, or... But these can't connect to each other, so I think if this... Oh no, that still works. These can't connect to each other. Got to... This goes here or here. Oh wait, this being here means this must be here or it would see this closer. Okay. Can I do that anywhere else? Oh, this. And point it at the wall right there. It's... okay, if this is 2... This is also 2. It does force this, but that's... Oh, that breaks down here. Oh, unless... Oh yeah, that doesn't break. Huh. Okay. What else am I looking for? Oh, there's no way. Yeah, that breaks. If this doesn't see something before this, then this... Wait. Yeah, then this break. Okay, so this either sees one here or here. 98. Oh yeah. Right, yeah, that breaks down here. Oh. Oh, this can't connect to here, that breaks this. Leaves this at a dead end. So this goes here, this goes here. Oh, this could slink up through here. That would force this and this, but I don't think that's a problem. And in fact, I think, oh well, this being all 4, I can't make a mini path. So let's see one here or here. That is... Oh, if this is the first thing this sees... that breaks this. And the only other way is if there's another one here. Let me see if I can, okay, so there's a... There's a shaded cell in each of these dominoes. And one in here too. One in each of these. Now I can't shade this. Because then I shade this and that's a dead end. So... And I do the same thing here. But it's a little trickier now because the loop can go off, or the path can go off this way. Now, I don't think I can put more than one shaded cell in these 4 cells, right? Because if I do, I'm gonna make a dead end. Oh no, I could put one here and here. Oh yeah, that's a little more... That would make... but if it can't go here... this is interesting, because... Oh, I also can't... Oh, I see what I'm doing. I see what I'm doing. I can't link up this to this. So, and if this goes this way, yeah, they both have to meet here. That breaks. So this does not go this way. Because this can't get out of this region without doing that. So this goes this way. Now, what... Oh, that makes this. Oh. Going this way makes a dead end, so that's that. Okay, that forces this. This goes this way, this links up there. Oh, if this... Okay, I know some part of loop crosses here because there's an odd number of dead ends here, and I need there to be an even number of dead ends in any thing before I connect them. Oh wait, if this doesn't... If this connects here, then this either goes here or here, and that's an odd number. So this does not connect here. This... Well, basically this can only... Yeah, I think... Now that can only... Okay, so this goes down there. So this goes up here. So this does enter here. That doesn't tell me... Oh, maybe it's this that will tell me if that... Oh. I think this... Yeah, this breaks loop parity. So I think this does have to... Right. There. Oh, and this... Can't go down there, so it goes there. So this... Yeah, figured. This goes there. Now, does that link up there? Oh, wait, this. There's also the issue of this thing. Wait. Oh, if this goes down through here, if these do not come here, then this is... The only thing that does is X this. So I guess that's something to watch out for. This... Maybe I am supposed to do more down here. Interesting. Never heard of canoe slalom. That's an interesting, path. Alright. Alright. Okay, I've been... Oh, this is forced just by loop parity up here. And the only thing I don't know about is this. And the only way I can possibly resolve that is by putting a border here? Oh, a line here. That's the only way I can ever resolve, like, whether this just goes straight down or goes there. Because no other clue... Oh, this is forced by this. Yeah, no other clue is affected by that. There's maybe something here? Oh, okay, wait. And I do know that it eventually joins this and goes this way. Oh, these cannot link up again. So that's... Wait. I think I've broken it, because isn't this part of the Yagelin grid? Oh, this is... Right, okay. This is shaded. I think that's for Stephen with, yeah. So that's one of these two. I know that this is never shaded. Oh, and this. Oh, and because this is never crossed by the loop does have to do that. So either this goes through here or else this is shaded. Well, I should probably... Yeah. I made decent progress. Alright. Yeah, I think I'll, call it there. Alright. Let's see who's on to raid. On Saturday, I will start Pragmata, which I've been looking forward to for a while. What is mouse PI for hire? Oh, it's a shooter star. Okay, okay. No, I'll raid. Alright, Nova Otari. Alright, on Saturday, Pragmata, then on Monday I will, try, I will do more of the 16 by 16 as well as more Rorschach's River. Oh, and the next Fortress Fillomino as well. Alright. Oh, no problem. Thanks for joining me. Alright. I will hope to see some of you Saturday, and bye.